proportions from the chapter 1, and the proportion section kind of reviews how to do all the different kinds of equations too. So it's kind of a good mix before you're into this chapter test. Okay, so let's go with a couple definitions. The first definition is going to be a ratio. So a ratio is just a comparison of two numbers. If I can spell right. I forgot I in there. Comparison of two numbers. And we write them using division. So we would write it as like A to B or like 1 to 2. So you might see a ratio written like this, like if you're at the horse races, or sometimes it says you have 2 to 5 boys to girls or something like that. So you could see it with the semicolon. Sometimes you might see it written as a fraction, or you might see it just A is to B. So A and B would be numbers. So that's what a ratio is. So a ratio is just one fraction, and it could be written in all those 3 different ways. A proportion, which is what we're mostly solving in section 1.7, right? Nope, 1.8 and 1.9. A proportion is where you compare two ratios. All right, so our proportion compares two ratios. So basically you have two fractions and you have an equal sign in between them and you compare them, or you can solve like a missing letter and use it to solve a lot of different types of math problems. What was the other? Oh, unit rate was the other definition I wanted to make sure you understood. The unit rate is per 1. So how am I going to write that definition? I always think of it as per 1. And so think of like miles per hour. So you have 1 hour. So your bottom part of your fraction is always 1. So in my ratio on the top, the B would be a 1 every single time. Do I want to change my color scheme? No. Okay, so let me show you some examples of some problems on this. Okay, so the first example, let me show you a unit rate because I just said per 1. That's kind of a weird example, but what if I had 500 miles that I have driven, and I've done that per 5 gallons of gas. So it'll give you like a situation and it'll say, what is the unit rate? This is actually, and I'll give an example of it too in my second example, this is actually used in the grocery store a lot when you're shopping. So if something is $10 and you get 16 ounces, how much is it per ounce? That unit rate will help you be able to actually really compare two different brands and know which one's better. So this one, I would take the 500 and I would divide it by the 5. So again, I want the bottom one to become a 1 to get it how many miles per 1 gallon instead of per 5. So I would divide those and I would get 100 over 1, or reduce it, divide them both by 5, either way you want to think of it. So it's 100 miles per 1 gallon. And you could think of that as 100 miles per gallon. Okay? And so that word per is always in there, per 1. So grocery store again would be like, if I have 20 ounce, or yeah, I get 20 ounces. Well, how am I thinking of it wrong? If they're 16 cents per ounce, or maybe they're 50 cents per gallon or something like that. So the 1 is the unit rate, which we actually don't do a lot of stuff with, but it's actually really helpful when you're if you understand what a unit rate is. Okay, so the next thing I really want to focus on is proportions and solving them. So proportions are where we compare two fractions, and let's start with a pretty basic proportion. So maybe I have 2:5 as 4 is to what? Okay, so here's a proportion, basically a fraction equals a fraction, and we have this cool cross product or cross multiplication way to solve these. So it has to be a fraction equal to a fraction because later in the semester we'll do ones where you have an extra or a third fraction, and this quick method doesn't work as well. So I'm going to take 5 and I'm going to times it by the 4, and that would give me 20. So I cross multiplied, and I'm going to put an equal sign in between, and we can go x times 2 or cross the other way. And we usually write, when we take x times 2, we usually write it as 2x. We usually like to write the number first, either way that we think of that when we multiply those. So then once we've done our cross multiplication, we can solve this equation. So here's our letter over here, our x, and we have a 2 being times by it. So the opposite would be to divide by 2 to get the x by itself on both sides, so that this one becomes just 1x or x, and 20 divided by 2 would give us a 10. So our x would equal 10 here. And a way to check your answer would be to divide both sides with your, oops, I put a little slash there, but to divide both sides. So divide 5, oops, well, let me just erase that. Okay, so if I divide 2 by 5 on this side, you can use your calculator. Is that the same as if I divide 4 by 10? Or if I reduce both fractions, do I get the same answer? So you can see that you can reduce the 4 over 10 by 2, and they would both be 2/5. Or you can take your calculator and go 2 divided by 5, which is 0.4, or 4/10, and then you can do 4 divided by 10 and see that's also 4/10 or 0.4. All right, so that's how you can check your answer, kind of putting it back in and double checking. So let's do a couple more proportions. And please stop me if you have any questions. I'm going to check real quick if anyone else joined us. Oh, I have a Jason in here too. That's it. I was checking if someone was calling because I couldn't get in. So good, I got 2 people in here. All right, so let's see. And then if you guys have a question, just stop me. But let's look at a couple harder proportions. So this first one's pretty basic. You probably did that in pre-algebra or 8th grade math, or it depends on your age, I guess, but in pre-algebra. So let's try one like, what if I have 9 over 5, and that equal to like 5 over x plus 1. So I'm starting to make it a little harder because it's not just a x there, it's got an x plus 1 in it. We're still going to do this the same way of cross multiplication, both directions. So this way, I'm going to go 5 times 5, which is 25, equals, my little pen is like blinking weird. Okay, and then this way you have 9 times x plus 1. When you do this, this part's a little tricky. You have to write it as distributive because the 9 is being multiplied by all of x plus 1. Make sure that you take that x plus 1 and put it in a parenthesis. That is the majority of why people miss these problems with more than one term in one of the fractions. Okay, then we have to solve this. So we're going to take and get rid of the parenthesis by distributing. So we take first the 9 times the x, which would give us 9x. Then we're going to take the 9 and times it by, the 1. That's what happens when you write with your mouse. 9 times 1 would give us a positive 9, and we still just have the 25 on the other side. So we're solving this equation. And so we got to solve for x. We got to get rid of all the numbers by x, and you always want to start with the number over next to it first, which is a positive 9. So I'm going to subtract 9 on both sides. It's going to cancel them here. Okay, and 25 minus 9 would leave us with what? 16 equals 9x. Right? And then from here, we have an x times 9, which is the opposite would be to divide. So we're going to divide those, and it doesn't go evenly. So let's see, we have the 9 on the bottom, 16 over 9, so they cancel here, and then it forms the fraction 16 over 9. 16 over 9 is, you can't reduce that, so that's actually your answer, and you could be done here. You don't have to change it to a mixed fraction unless you want to. To change it to a mix, you just go, well, how many times does 9 go into 16? It goes 1 time with 7/9 left over. But you can leave it this way on almost all the problems. Some of the multiple choice might make you switch it. Okay, so let's try. I'm going to give us a new screen. And let's try one more. Oh, I was hoping the blinky thing would stop. Let's try one more, a little bit harder one or two. I have a word problem too I want to do with you. So let's see, what if we have, I think it's my third. Oh, yeah, that does come in darker. I think that's better. What if I have 5 over 2n and it equals 8 over 3n minus 24. Okay, so here is one that has a couple things by the letters, and you have more than one letter. You still have a fraction equal to a fraction. So we can still do the cross multiplication method. So let's start this way. I can take 2n and times it by the 8. So we have 2n times by 8, and then we'll actually do that in a minute. You could have done that on that step. And then 5 times the 3n minus 24. So remember, again, you have to do 5 times the 3n minus 24. I need a parenthesis around the term with the plus or minus sign in it so that I remember to distribute. So 2n times 8. 8 times 2 is 16n. Okay, and then this side, 5 times the 3n would give us 15n. And then 5 times 24, bring down the minus sign. 5 times 24 is what, 120? I had to cheat and look at my calculator. Okay, so 5 times 24. Okay, then from here I have 2 letters. So this goes into that other section you were doing in like 1/6, I think, or 1/5, where you have to subtract them together. So basically this positive 15n, I'm going to minus it to the other side so that I get my letters together. So if you have 2 letters, you have to get those together first to be able to solve it. So these ones would cancel, and I have 16n's minus 15n's, which would give me 1n, which I can write as just n. Okay, which is kind of nice. Over here, keep the minus sign with the 120, so it's like a negative 120, because this part went to 0. And we already have 1n is equal to negative 120, so we have our answer already there as negative 120. We could put that answer back in both spots and calculate these fractions and make sure they're equal. That's how you could check your answer and make sure they're correct. And I did check that answer, so I know that one's right. I am going to now pull up, I saved it in my videos or pictures, a picture of a math problem. There it is. Oops. I'll just do it this way. All right, so then I'm going to have this math problem. I just did print screen, but we can just do the problem right under it. It won't be a big deal. All right, so this problem I just stole straight from your book. I print screened it over, and here it is. So this problem says, well, I have a particular shade of paint. It is made by mixing 5 parts red with 7 parts blue. So that's how you make that paint to make this shade. Shannon mixed 12 quarts of blue with 8 quarts of red paint. Did she make the right shade? So, don't show me this message again. So on this one, you got 2 different things. It gives you the ratio that it wants. It wants 5 red to 7 blue. So let's write that down. It wants 5 red to 7 blue. And what we're checking for this is, does it equal what Shannon did? Well, she has 12 quarts of blue, so we have to put blue with blue. Okay, and she had 8 quarts of red. So you can cross multiply and see if they equal each other, or reduce the fractions. I think it's easier just to multiply across and see if it's right. So 5 times 12 is 60. Does that equal 7 times 8, which is 56? Well, nope, they're close, but no, you're not going to get the same color. So here's an example of a problem that you would see in the real world, like, am I doing this correctly, or how I can use proportions. You have a whole section, 1.9, on applications of proportions, so they get even harder than this one, that you work out different proportion things. So this was like a basic overview of proportion. So what I'm going to do is stop my recording and then answer any questions that you guys might have on any problems. So if I can remember how to stop my recording, maybe it was Control. Maybe it was this one. Nah,